In this section, we're going to talk about differentiation rules from polynomial and exponential functions. Finding derivatives of functions by using the definition of the derivative can be a lengthy and, for certain functions, rather challenging process, as we found. For example, we previously found that the derivative of the square root of x, so I'm going to write that down, so the derivative, so if I had f of x equals the square root of x, we found that the derivative of that was 1 over 2 root x. And the way that we found that was by using a huge process that involved multiplying an expression by a conjugate prior to evaluating the limit. That wasn't so fun. So here's the great news, you guys. In this chapter, we're going to actually develop rules for finding the derivative that is going to allow us to bypass this crazy long process. So let's begin with some basics. All right, let's start learning some rules. So let c be a constant. If the f of x equals c, then the first derivative is 0. If we think about why, if the function is a constant, that just means it's going to be a straight line. Well, what's the derivative? The rate of change? It's not changing, so that's why it's 0. So we're going to learn some new notation. Instead of always writing f prime of c, some new notation that we can use is we can say d over dx. So that means you're taking the derivative of the function with respect to x of c equals 0. Let n be a positive integer. If f of x equals x to the n, then the first derivative is n times x to the n minus 1 power. So again, if I use Leibniz notation, we would say the derivative with respect to x, so d over dx of x to the n. So this means taking the derivative of this function with respect to x, and that is n times x to the n minus 1. All right, so let's do these. So again, you can see down here in this example, I've got d over dx, so that means find the derivative of 8. Well, 8 is a constant, so that means the derivative using this formula here is just 0. All right, letter B, take the derivative with respect to x of x cubed. So this is a power, so we can use this formula. X to the third power is going to be 3 times x to the n, so 3 minus 1, which is 3 times x squared. All right, the derivative with respect to x of the square root of x. So again, this d over dx means to take the derivative with respect to x of the square root of x. So we can rewrite, I'm going to go up here just so we have a little more space. Right now we don't have a formula for a square root, but we do have a formula for a power. Now, remember, I can rewrite square roots using that rational exponent rule, so I'll write that over here. A to the m over n is the same thing as if you're taking the nth root of a to the m power. So I can take a radical and write it as a rational exponent. So this is the same thing as x to the first power, and you're taking the square root. So I could rewrite this as 1 over 2. So x to the 1/2. Okay, so now if I apply this power rule, that's going to become that 1/2 goes in front, because the power rule says if you're taking the derivative of something to a power, you move that power in front, and then you subtract 1 from the power. So that's going to be 1/2 times x to the 1/2 minus 1. So that's going to give me 1 over 2 times x to the negative 1/2. So now we're going to have to use some properties of exponents to simplify this so I don't have negatives as exponents. So that's going to be the same thing as 1 over, so an exponent rule tells us I can move this term into the denominator by changing the sign of the power. So that's, if you have a to the negative n, you can rewrite that as 1 over a to the n. Okay, and then I can just rewrite this. Now let's go back to a square root, because that's what I started with. So that's going to be the same thing as 1 over 2 times x to the first power, and you're taking the square root, so that's just the square root of x. So this went back to, we did this way back in the earlier chapter where we did it the super long way, and it took us forever, and there was a lot of ugly math with multiplying by conjugates. You can see here, even though it shows that we still have some steps to work through, it's much simpler. Okay, let's just keep on using this power rule just so we can get a little bit better at it. So if I have x to the 43rd power, all right, so again, I'm going to write this up here. So d over dx of x to the n equals n times x to the n minus 1. Now, all of the rules you're going to be learning in this section, well, in this chapter, all need to be memorized, and they're going to really help you to have those memorized now, especially when you go into the next math class and we do integrals. So what I usually recommend for helping you memorize when we have a bunch of formulas is write them down every time you use them. The other thing you can do too is create flashcards. You can create paper flashcards or you can create them digitally on your phone. There's a great app called Quizlet that I usually use. It's a free app. There's lots of great apps out there for it. Okay, so if I was finding the derivative of this, so I'm going to write this using Leibniz notation, okay? So this would be the first derivative of x equals d over dx of x to the 43rd. Because I'm taking the derivative of that function. Okay, so using this formula, I get 43x to the 43 minus 1, which is 43x to the 42nd. All right, 1 over 2 to the 7th. I don't quite have it in this format, but I can change it to that using properties of exponents. So I can rewrite this as t to the negative 7th power. Okay, now again, I'm going to use Leibniz notation. So I'm going to show here, I don't have like a z of t written here. So the way that we would show that and write that as a derivative is we'd say the derivative of the function z with respect to x. So we call it dz over dx. So that's going to equal taking the derivative of this piece, okay? So I could write that step out. You don't have to write that part out, but I'm going to. All right, so that's going to equal the derivative of t to the negative 7th over, or with respect to t. So again, I'm going to follow this power rule. I move that power in front, and then I subtract 1 from the exponent. So I get negative 7t to the negative 8th. I'm going to write that using positive exponents only, so we'll move that to being underneath to getting that positive exponent. Okay. All right, looking over here for letter C. P equals the 5th root of t squared. All right, so Leibniz notation, the derivative of this function with respect to t, because that's the variable that we're using here. All right, so let's rewrite this 5th root of t squared. So that's going to be using that property of exponents. It's going to be t to the 2 over 5 power. All right, so now I can use, now I have it in this form, so I can actually use this power rule. So that's going to give me 2/5 times t to the 2/5 minus 1. Get that common denominator, so multiply this by 5 over 5. And that's going to give me 2/5 times t to the negative 3 over 5. Again, I want to make sure that I'm writing it with positive exponents, so I'm going to move this term into the denominator so I can make that exponent positive. So 2 over 5t to the 3 over 5, and then let's go back and rewrite this as a radical, since that's what I started with. So that's going to be t cubed, and we're taking the 5th power. Okay, and then this last one. So the derivative h prime of x, whenever you've got in function notation, you can just use that notation. So that's going to equal, I'm going to again get this into that same way that I can actually evaluate it. So 1 over the square root of x is the same thing. So that's 1 over x to the 1/2 power. So that's going to be x to the negative 1/2 power if I move that up into that numerator. Now, I'm sorry, I missed putting d over dx. That's important. So we got to say we're taking the derivative of that. Let's make this a little prettier. D over dx of x to the negative 1/2. All right. So now I can apply that power rule. So that's going to give me negative 1/2. So when I take the derivative, notice I don't have d over dx or d over dt because I actually have applied that now. So move that up. And then we've got x to the negative 1/2 minus 1. So I get negative 1/2 x to the negative 3/2. So negative 1/2 move that to down here. All right, so now let's write it using radicals. So that's x cubed, and you're taking the square root of it.